Greetings everyone, this is Sambhav Jena 20MF10032 and Soumya Ranjan Jena 20ME30061, and this is our submission for the Mechanism Sessional Group project, which is a part of the 2 credit course Mechanism Sessional ME29002 under the Department of Mechanical Engineering, IIT Kharagpur. So for the problem statement that we are working on, it is the windshield wiper mechanism. Now the graphical part of the solution will be explained by my team member Soumya Ranjan Jena, and I will be explaining the numerical and simulation part. So handing over to Soumya for the explanation.
So as we can see, the question is given that we have to synthesize and make a simulator for the windscreen wiper mechanism. So we know that the motion of windscreen wiper mechanism, how it moves. So to explain that, we saw the diagram that here we are considering the 4R linkage mechanism, which consists of point O2, A, B and O4. So how the next diagram will show the solution of how it is solved. So we see that it moves and it has some extreme position. To locate the extreme positions, we know that it has two dead centers. But the first dead center will be formed when the points A, O2, B will be in a straight line. So when this happens, this will be an extreme position for the wiper where the point C is located. Another dead center configuration will be the point O2, A dash and B dash will form in a straight line, and the wiper will be in C dash position. So to draw this configuration, we take the point O2 and draw the arcs O2B. Also take the point O2 and draw to B dash, and the O4 from O4 point we draw O4B arc and O4B dash arc, and we join the lengths to form the dead center configuration, and the delta angle is also given. According to that, we draw the lengths which we require from given our question. So the area will be there. The shaded portion which is given is the area wiped by the mechanism, where the extreme positions of the wiper are C and C dash.
Now let us take a look at the numerical analysis and MATLAB simulation part. The given problem has a fixed geometry and is subject to certain geometrical conditions. These geometrical conditions are given in the question itself and are existing on the basis of geometry and orientation of the wiper, and due to the fact that it has rigid bodies that cannot change length. So let me take you back to the question now. Here in the question we can see that certain things are constrained, like the vertical distance of O2 from O4 is fixed at 50 millimeters. The horizontal distance of O2 from O4 is fixed at 150 millimeters. The angle delta is fixed at 10 degrees, and link AB has a fixed length of 200 millimeter. Likewise, EO6, O4B and O4C and every other link has a fixed length which cannot change. Now these are the geometric conditions which are imposed. Now with those in mind, we vary the coordinates position of the crank. Now as the position of the crank varies, all the other factors that depend on it, they also vary, and this brings about the displacement analysis. So the displacement can be found by finding the location of the coupler for every position of the crank using these geometrical conditions. So what we do in MATLAB is that basically we provide the conditions of the links, like the lengths of the links and the geometrical constraints, which basically position the link with respect to its environment, and then based on that we rotate the crank. And how do we move the crank? We set it to rotate about a fixed point and then plot the coordinates of the crank as well as the other links that depend on the position of the crank, since the entire thing behaves as a single mechanism. This is enough to bring about the movement of the wiper and the final link that causes the wiping action, final wiping action. Likewise, the velocity analysis can be done by Jacobian analysis, but this is not really the focus of what I am done in this problem statement. So now let us take a look at the simulation. Before that, let's have a brief look at the code. So in the code, initially we are specifying the lengths of the links as well as the position of the links, where they are located, and the various constraints. Now the constraints are given from the various angles, like the angle between the various links, the lengths of the links. Like there was a particular case of delta given was 10 degrees, so that and other conditions, those are implemented, And after the entire setup is made, like after we set up the entire mechanism, so first we build up the parts and then we make it move. So after the mechanism is set, we try to rotate the crank, and as the crank rotates, as its coordinates changes, the its effects are seen on the coordinates of the other links of the mechanism, and thus the entire windshield wiper mechanism moves. But what is our focus here is the motion of the ultimate wiper which carries out the wiping action. So now let's run the simulation and have a look at the results. So this is the simulation. The angle between the extreme configurations is comes out to be around 26 degrees based on the parameters input to the question, and the simulation shows the motion of the windscreen wiper as it moves from the dead center configuration of one dead center configuration to its other dead center configuration, bringing about the two extreme positions of the wiper. The red zone marks the area wiped by the wiper mechanism. Now this area can be changed by changing the various lengths and the geometrical constraints. However, the geometrical constraints are fixed in the problem, so I am not going to do anything with that. But we can obviously change the lengths of the links. So this is the animation, the red zone showing the area of the wiper. Now, with the simulation done, let's take a look at the results. So as we can see, the wiper is restricted to two extreme positions, one on the left and one on the right, and all the wiping action is in between those two extreme positions. And these extreme positions correspond to the dead center configurations of the 4-bar linkage O2O4AB as explained by my friend Soumya Ranjan Jena in his initial explanation graphical solution. And third conclusion that we come across, that the given mechanism is a crank rocker mechanism. So that's about the windshield wiper mechanism. Thank you.